Okay, welcome back to our part 4 sensors and actuators, part 4. This time we'll be using a PIR sensor. So, what is a PIR? It's a passive infrared sensor. Okay, so infrared light is invisible to the naked eye or to the human naked eye, but if we're going to use a camera, more or less you can see the spectrum of the infrared color. Okay, so infrared PIR sensor is used for motion sensor. Okay, so it can sense the IR infrared heat signature of an animal or human beings. Okay, but take note, it must be there must be a motion. If it is static, then the PIR sensor is unable to sense. No, so we're going to integrate, okay, the PIR sensor with our existing relay. Okay, so this time the relay is powered. This is a 5-volt relay, no coil. So it is self-powered by the Arduino. Okay, to ensure that it will switch, no, or turn on the relay or actuate. So we use of the BGT amplifier or the transistor rather, the BGT NPN transistor. Then the supply is the 220 volts assuming alternating current, but it's generated using a virtual function generator. It's not an actual function generator because it can reach as high as 220 volts. Okay, so how is PIR being connected? So actually there are three terminals. Okay, one is the signal terminal. The other is the power. So in this case, we'll be utilizing the 5 volts power. Then the other one is ground. Now there is commercially available uh, solar LED lights, no, that has a small solar panel, of course, with a lithium-ion battery inside, and this PIR sensor. No, usually it's a small one that is placed uh, outside the door. No? So including a photoresistor or a phototransistor, no? Or a photo light sensor. Okay. So every time in day and night time, in night time, whenever there is going, no, to the door near the door, so the PIR sensor will sense that there is motion, okay, by human being. Then it will automatically turn on the LED lights. The PIR sensor is already also installed in uh, lights, no, in fluorescent lights. No, there are a version of it, as well as on the air conditioning unit, and so on and so forth. Okay, okay. So we're going to connect this PIR sensor. So the signal is being connected to D2. Okay. Then of course the power is the 5 volts and the ground is the ground. Okay, so let's look at the code. So this code is not an example code in TinkerCAD. So I created this one. So I've declared, this is very important, a global variable time 1 and time 2. So to tell the difference between the current time and the increment time, no? Difference, time difference. Okay, so it's very important that the variables are global because if you're going to put it here, as this loop function keeps on looping, so the value of your time 1 is always initialized to 0. Okay, so it will always reset to 0 as well as time 2. So that's why it's very important that time 1 and time 2 is outside the loop, no? Or better yet, it's outside, it's the global, no? Global variable. Okay, so I've declared here a local variable. Okay, so the PIR, so the value of the PIR sensor, so which is assigned to digital read. So it must be an input device. Okay, so that's why it's digital read. And PIR is not analog, it's digital. So that's why in the pin mode, so 8 and 2 are utilized. So the 8 is for the relay, the 2 is for the PIR, and it must be input, whereas the relay is output. Okay, so including the serial communication so that we can monitor the different values accordingly. Okay, so we need to set the equation. The time 2 is the difference between the current time, which is milliseconds. Okay, so take note, this is the current time in milliseconds. So as this is the time spent, no, as the Arduino is turned on, since the Arduino was turned on. So this is the current running time. So it's expressed in milliseconds. That's why it's milliseconds. Okay, it's the current function. It's the current time function in milliseconds. Of course, the time one. Okay, so you subtract the current time with the time one to know the difference between time one and the current time. Okay, so we have here control, no? So if the PR is high, so which means that sense, no, it can sense, it can motion sense a human being or a living things. Then that's the time you set your time one. No? Time one is set to the current time, so that is milliseconds. After you have set the time, no, time one, then you activate the relay, no, to turn on the lamp or the bulb. Okay. So when are you going to turn off the relay? So you're going to turn off the relay if the PIR is low, and this time we're going to use relational operation. No, this is double ampersand. It means and. No, PIR is low and time 2 is equal to 2 seconds or 2000 milliseconds. So therefore, if the difference of the current time, you know, with respect to time 1, or simply uh, the time 2 is the time spent after you mark time 1, or simply the time spent after that the PIR becomes high or logic 1. Okay, so you turn on the relay. Okay, then if it is low at the same time, the time difference is greater than 2 seconds. So which means that there is no motion detected in your PIR sensor after 2 seconds. Okay, so the PIR sensor has also a manual delay, no, in the circuit of the PIR. So you can also set that delay, no, instead of adding this this value time to greater than 2000, you can set it manually, and therefore there's no need for this second statement or condition. But since this PIR, existing PIR or virtual PIR, doesn't have a setting for the delay, so therefore this is just adding a delay, and time 2 is greater. Then, if it is greater than 2 seconds, so it means that after 2 seconds, there's no motion. So that's the time you turn it off. And there is no bracket here, open curly brace because there's only single statement. But anyway, you can also write uh, uh, curly brace here and as part of our monitoring here, we're gonna monitor the values of the PIR as well as the time too, so that we could determine if the the switching, no, the switching on and the switching off of uh, the our lamp. Okay, so we're gonna make it this a little bit small. Okay, so our code here. Okay, so we're gonna move this a little bit. So take note the relay, no, the common contact is connected to the virtual 220 volts. Then the normally open is connected to the lamp going towards to the neutral of the alternating current supply. Okay, so let's start. Okay, so this first column, okay, the left column is actually the PIR. So which means it has value equal to 0. Okay, then the next column is actually the time difference. Okay, so initially time 1 is 0. Okay, so what will happen if, okay, so we're gonna make it small. What will happen if I'm going to, uh, okay, so this is the acceptance cone of the signal of the PIR sensor. Okay, so it can detect, no, detection zone. Okay, so if I'm going to move this one, so you notice that the PIR sensor detects a motion. Okay, so there is a certain delay. Okay, that's why the value of the PIR sensor was 1 and now 0. However, the lamp keeps turning on, okay, because it will only turn off if the time difference is 2000. Okay, so let's check. Oh, there you go. So, okay, so the lamp is already turned off. Okay, turn off. Then of course, the PIR is already turned off. So you notice here that the time 2 is actually past 2000 already. No, that's in fact it's around 5000. Okay, so let's play it again. Let's detect it again. Motion. So there must be motion. Okay, so the lamp there is 60 hertz, turning on 60 hertz. That's why it's blinking because it's our similar. Okay, so now the PIR sensor is 0, is unable to detect motion. But then again, the lamp is still turned on. So what if somebody moves again? Okay, within the time period. Okay, so we know that sometimes people sit down, okay, or just don't move while standing. Okay, so to continuously supply light, no, there must be this delay, no, so that it will not be blinking, constantly blinking from time to time, that it will move and it will not move, move, not move. Okay, so it's now turned off. Okay, so hope you'll appreciate this this circuit, no, or particularly this PIR motion sensor. You can also tandem this with ultrasonic sensor to ensure that there is uh, somebody is standing, no, because it can measure distance, no, certain distance, obstacle distance within its a zone, no, detection zone. Okay, so you can tandem this with ultrasonic, okay, to improve the performance of the uh, light light control, no, lighting control. Okay, as well as the ventilation as well, no, you can control the ventilation as well as the lighting control. Okay, so bye bye.